In the previous videos on vectors, I introduced the idea of a vector and tried to explain why the vector quantity or thinking about direction of quantity was important. So let me just review. When you finish watching these videos, you should be able to explain what is a vector quantity and a scalar quantity and explain why it is important to consider the vector nature of quantities. On the previous video, we looked at this example of walking in a city and how different paths caused you to walk the same total distance but different displacements. That is, if you wanted to know where you are, you'd have to consider the direction of your walking. On the other hand, if you only wanted to know how much exercise you got, you only had to consider the total distance and not worry about the direction. Now, I made these statements here, 3 meters plus 3 meters, that is 3 meters, this was east, and 3 meters north, gave you a total displacement of 3 times the square root of 2. So how do we get that? Well, many of you can see that that's just a Pythagorean theorem use. And so I'm going to talk a little bit more about how we can put two vector quantities together. So in that case, we had a 3 meter displacement to the east, and I'm going to represent displacement like we do all vector quantities with an arrow. And so sometimes this arrow itself, this representation, is called a vector. And then I'm going to draw a 3-block vector to represent the distance that the displacement that I walk north. Then combining those two gets me a vector like this, which has a magnitude of 3 times the square root of 2 and a direction of 45 degrees north of east, or in the northeast direction. Now, the way we put vectors together like that is fairly straightforward. Take one vector and place the second vector, tail of the second vector, to the head of the tip of the first vector. So if I walk 3 meters east and then 3 meters east, I can represent the first displacement with an arrow like that and the second displacement with an arrow like that. And then to find my total displacement, or to represent it at least, again, I can come over here and make a connection between the tail of the first and the head of the second. So, like that. And that is a vector that represents a 6 meter displacement. In my last example, I walked 3 meters north, so there's a, 3 blocks north, so there's a 3-block vector. And then I have another motion in which I walk 3 blocks south. There is a vector representing 3 blocks south. The total displacement then is simply a vector drawn from the tail of that to the head of that, and that has no length whatsoever, hence no displacement. So when we want to represent a vector, the length of the arrow represents the magnitude, and the direction that it points represents the direction.